Hello everyone, it's Dr. Grayson again. I hope you are doing well. This is the final screencast for our Titanic data analysis that we've been working on for this past several days. And what I'd like you to do is to get out your worksheet, as I have in front of you, and this is the third worksheet in the assignment that we're doing for the data analysis Titanic survivors. So what we're going to work on today is an activity on regression. And if you remember, regression, we use a regression analysis in marketing to help us make predictions. And in statistical modeling, regression analysis is a set of statistical processes that we use to estimate the relationship between the dependent variable, or sometimes we call that our outcome variable, and one or more independent variables, sometimes called predictors, features, or covariates. So what we're trying to do is we're trying to create a model to help us predict our outcome. And a regression model is a linear model, so we try to fit all of those predictors in a way that gives us the most likely prediction that these particular independent variables will explain the outcome. So if you look at what we have here in terms of our database or our analysis that we've been using, we want to look at analyzing the Titanic data. And if you recall, if you think about the Titanic, it was coined the unsinkable ship. So some people believe that it was a curse when people were saying the ship is unsinkable, and that's why it demised when it hit the iceberg. Other people just believed that because it was deemed an unsinkable ship, the crew really didn't pay as much attention as they should to taking safety seriously. So whatever conspiracy theory you might have, let's think about how we might be able to take this data and make a prediction on who is the most likely to survive this particular horrible tragedy. So some people have said, well, if you think about what they always tell you about ships, women and children are always the first off, encouraged to leave the ship first. Well, that could be one prediction. Other theorists, if you've watched the movie Titanic, believe that if you're in the third class or you're down at the bottom of the ship, you're less likely to get off the ship in time. So that might be another variable that we're interested in looking at, whether, gender or age or ticket class. So let's take a look here at how you might go about creating this particular analysis. So think about it. As you're looking at your worksheet here, what I want you to do is to open up your coded data. So here we have it here. Remember, you've got your workbook that you've been working on for descriptive statistics and correlation, and now we're doing regression. So go ahead and just simply open up that workbook, and we're going to start working right in your data tab here. So let's do this. You've already have your analysis your analysis data pack loaded onto Excel. So you're going to, for regression, we're going to go into data and follow the steps I have right on the worksheet. Data analysis. And then as a dialog opens up and you have all of these various analysis tools that you see, we are going to select regression and then select OK. Once you've done that, then we have to put in our ranges. So when you think about the thing we're trying to predict, we are trying to predict whether somebody lived or died. And as you recall, that would be what we labeled state, meaning one has lived and two is died. So we're going to highlight that entire data selection. You can hit enter once you have it done, or hit this little box here. So that's going to be our dependent variable. Now let's try to see what we can use as predictors to see whether or not which variables we think might predict live or die. So what I'm going to do is I'm going to select these here. I'm going to select passenger class, because remember, some people said if you're at the bottom of the ship, you might have a worse chance of surviving. Gender and age, women and children off the ship first. So that's my prediction is I think these three variables in the set of the Titanic data might predict to some extent your likelihood of surviving. So I'm going to take those three variable rows and I'm going to just scooch all the way down here. Once you have it all selected, hit enter. All right, well then let's go back to our dialog box here. We know that there's labels. So we have to, our data has labels. We're going to select the labels. The next thing we're going to do is we want to make sure that this confidence level is set at the 95% because we want to be 95%. Remember, that's what we use in business. And then what I want you to do here is, as we've done with our other worksheet, you're going to name this. So we're going to name this regression. All right. And if you like, you could do some plots here, some normal probability plots. I'm just going to check that for kicks. So once you have all of that data in there, select OK. And voila, look at this. Our regression table has popped up here. So this is our regression table for our regression model, of which we chose the intercept, or whether somebody lived or died. This is our dependent variable. And then each one of our predictor variables, what class ticket they had, are they male or female, what is their age? Because we predicted that these three things might explain whether someone lived or died. So let's look at the things that we look at when we're looking at regression. One of the main components that we look at here, and I'm just going to highlight it for you, is what we call R-square. And R-square in our model indicates that gender and age account for 36.8% of the total variance. So R-square is the prediction of, or the explanation of all of our data. And of those three variables that we've chosen, what percentage or what is that particular measure of goodness? How well do those three things predict our model? So when you're looking at this, what we want to do, a perfect prediction, as we know, is 100% or 1% correct. So when you're looking at regression, the closer you get to the number 1 in your R-square, the more explanation you have for those predictor variables. So in our case, you look at regression of these three: passenger, age, and gender, and you're like, well, 36% is telling us something. But, you know, it's really not all that great, right? Wouldn't you want to be more like 80% or 90% predictable that, you know, you might live or die, or if you're one of these three things? But it's interesting to look at. The other thing we often look at when we're looking at a regression table is the standard error. And standard error is a goodness of fit measure, just like R-square, that shows you the precision of the regression analysis, meaning the smaller the number, the more certain you can be about your regression equation. So this is going to describe the error. So a small number would be 0. So here we've got, you know, from an error perspective, it's you know, it's okay. It's not, there's not a ton of error here. It's 39. So you can kind of, generally when we look at regression, we're mostly looking at R-square, but it's good to just kind of see these goodness of fit measures as well. Another thing you look at here is the significant F. And this is the significance of our model. And remember, we looked at this as well when we did this in correlation. So in terms of significance, what we want to look at is that, is our F value here less than 0.05 or 5%? If it is, your model is significant, meaning the strength of it is pretty good, or you're pretty confident that you're within your range. But look at ours. Ours is over 1. So when I look at this and I know that I'm looking for a significance level of my model to be less than 0.05 or 5%, I'm thinking that this probably isn't the best model ever. I may want to look at some other types of variables that might explain more accurately whether people lived or died. So I want to show you one other thing here as you're looking at regression. So this is very similar to, well, it is identical actually, to our correlation table. So if you remember when we did a correlation table, we looked at those things that we believed had a correlation with whether someone lived or died. And remember, we called that a coefficient. And so if you look, just like we did when we looked at correlation, gender had the strongest at 0.49. Remember, the closer you are to 1, the stronger the relationship between the two variables. Because a relationship with gender and gender would be 1, because it would be perfect. You're looking at it against itself. In this case, it's 49. So again, it's sort of middle of the road. It's a medium sort of relationship. Another thing that we look at here could be, your other variables. So passenger class is, explaining about 18. And then age, very, very little. So if I were to look at these two variables as it related to my explanation of whether passenger class and age have a relationship or predict whether somebody lives or died, I might say that these two here, passenger class and gender together, might be, might have some level of explanation. But when you take all of these variables together and you run them, that's where your R squared comes from. So all 3 of these variables together, this is your predictor of whether or not you think these 3 variables have a relationship or predict the likelihood of somebody to live or die. So in our model here, our model's not great. It's not significant. It's fairly low. We can see here that gender still, as we look at our coefficient, is pretty high. But when you take all of this variability together, it doesn't explain very much about what our model says. So what you'll need to think about that as you think of whether our model of women and children and ticket class explain the likelihood of whether somebody lives or dies, our prediction is pretty weak. And there's probably other factors, many, many other factors on the ship, or weather, or a number of other things that explain this. But it's a good exercise for us to go through, and I'm interested in absolutely running through regression on all of the data that you're collecting for your semester-long project. So I hope this makes sense to you. Again, what we're looking for in regression is to develop a model that has the best fit of showing us how strong or how likely our independent variables together predict an outcome. So thanks a lot, and I hope you all are doing well, and I look forward to wrapping up this assignment so we can start getting working on your projects. Take care.